So I'll introduce myself. My name is Swetha. I work for IBM. I work as a part of a team called the Open Technologies team. So we basically do open source in different types of fields. Mostly our team does cloud. So we do things like Docker, Kubernetes, and those kind of things. And then I'm on the blockchain. So I work on Hyperledger Fabric. And then specifically in Hyperledger Fabric, I've been spending the last about year and a half really focusing on the EVM integration that we've done, working with the Hyperledger Burrow project. And really what that project's all about is adding portability of Ethereum smart contracts and applications so you can run those on Fabric. But I'm not going to talk about that today. But if you are interested in that, please do find me either after this session or somewhere around the conference. I'd love to talk to you about it. And really, I'm going to go into Fabric. So I think Fabric is a very kind of unique blockchain. The real big thing about it is that it's been designed for enterprises. It's been designed with the thought process that this should build upon the business networks and business relationships that already exist. And we want to bring in a blockchain network that improves the processes that are already there. And use them, right? We're not trying to recreate or do something completely fresh. We want to use what's already been built. So using that kind of as the backdrop, that kind of informs a lot of the design choices that were made in Fabric. And just to kind of highlight, I'll start off with some use cases, because I think a lot of people are always interested in that. So the first one I want to talk about is Hyperledger. Are people familiar with this one? I see a couple of nods. No? So basically, Hyperledger is there to track diamonds from the mine all the way to the retailer. So when you buy a diamond, and if it has been on the Hyperledger, you can actually see the entire history of it. And it's based on the diamond. Like, there's a unique fingerprint they're able to generate just from the diamond. They don't have to like put in an ID or anything, which is kind of cool. I don't know the science behind that whole piece, but the nice thing about it is now, because of this, you can track things and make sure that you own a conflict-free diamond, right? And especially in the stones and the precious stone stuff, there's a lot more incentive to be fraudulent, try to pass off stones as real, as authentic, and make up certificates and stuff like that. But with something like Hyperledger, you're able to kind of see the history, and it's harder to kind of add in a different point all of a sudden and say, oh, here's a certificate, it's just not on the blockchain, it doesn't make sense. So it's neat for that. And then some of the other things that it's nice is like it's also increased transparency. So when you're kind of getting your diamonds insured or you're trying to get a claim, you have a record, right, of where it's from, and you can prove that it's real. So another one that I think IBM, really, we like to talk about this one, is the Food Trust. IBM worked with Walmart to kind of create this blockchain network. And the idea is that we want to be able to track produce from the farm all the way to the retailer. And then the real core benefit you get from this is when we have recall situations, we know exactly where it came, and it's easier to figure out what needs to be removed, how do we react to a situation like that. And in general, I mean, people are becoming more and more curious, right, of where is your food coming from and things like that. So again, this is increasing transparency. This is also a supply chain kind of a use case similar to the diamonds, but just a different kind of good, right? Diamonds are a little more expensive luxury good versus food, lettuce. Those are common things that people eat all the time. And then the last one I want to talk about is our TradeLens network. So the TradeLens network was started with IBM working with Maersk. Maersk is the shipping company where they kind of deal with a lot of the logistics of moving one container from one place to another. And the idea here is, again, we're going to use blockchain to be able to track these containers throughout. Now, there are a few things that were there before blockchain that kind of made this process a little difficult. One thing is that they had literal paper trails in the sense that everything was paperwork. So when you go to a port or anything, since it wasn't digitized yet, it just takes time to go through. And when you're looking at pieces of paper with signatures and stuff like that, it's a lot easier to duplicate and make up. And with that, people can definitely use the fake documents and ship counterfeit goods throughout, right? But you can't really validate. So with the blockchain, it's a little bit easier to catch the fraudulent kind of containers. The processing time, just because it was paperwork and it was a pile of things, and it depends on what's on top, right? That gets processed first. What could happen is shipments that maybe contain like bananas or apples, things that go bad, they could be sitting in a port for weeks or months. And when you have food or things like that, getting those things processed quickly is very important, because if the food goes bad, that whole shipping, you just lost. It's a loss, right? So that's kind of what TreyLens is there to be, and it's more about, again, so all of these things, all three of these are more supply chain, some kind of a logistic. You're tracking how these assets are moving through. And I think that's like fairly a pretty good use case of how Fabric works. But let's kind of dive more into what Fabric is and how that works. So the key things, I'm not going to go and do a base blockchain 101. I'm hoping that everyone kind of has that. But I'm going to try to talk about the things that are different about Fabric. Number one, it's permissioned. When we say permissioned, we mean it in a few different ways, right? One is who's allowed to run a node in a network, right? Who's allowed into the network, and then even who's allowed to see the data. You have permissioning at different granularities, and it's highly customizable. So you can really pick where do you want to be very strict, where do you want to be more flexible, where do you want to share the data. The next thing is highly modular. So we designed Fabric as a way, like it's not a single use case, but we want you to be able to bring, adapt Fabric to the use cases that you have. So that can mean a few things, like we have different consensus options. Before it used to be Solo and Kafka, and as of a month ago, we now have Raft, which is exciting. You have different backing databases that we have an option for your ledger, how you want to deal with membership, and then endorsement and validation I'm going to go into a little bit later on, but that's just part of the way we deal with consensus in Fabric. Smart contracts. So smart contracts are typically, like, how many people here are familiar with Ethereum and things like that? Okay, that's a good. So if with Ethereum, right, they created their own a new state machine, and with the new state machine, they also created new languages, Solidity, Viper, and those are like contract-oriented languages. Fabric goes with the approach that we're going to let you use general purpose languages. So you can use Go, you can use JavaScript, you can use Java, and you can make your smart contracts using those codes. There's some APIs that you or interface layers that you have to interact with, so that way you can talk to our ledger. But other than that, you're writing just a little piece of code. And I'm going to use the word smart contract and chain code interchangeably here. Chain code is what we call the smart contract in Fabric. Privacy. So privacy is another thing. We give ways to shard the ledger, so that way not everyone has access to every transaction that's happening in the network, right? It doesn't usually make sense. In a business setting, you don't need to know the dealings of, you might be working with someone, but you don't need to know everyone they're working with necessarily. So there are ways to keep some data separate. And so that goes from ledger versus data just into a smart contract. We have like a private data options. We don't do mining. We don't have a cryptocurrency or anything like that for consensus. We will soon be having might have a token added into the Fabric network, which would be optional, and I'll kind of give you guys an overview or talk about that a little bit later. And then I think the last thing, and this is an important distinction with Fabric, we follow the model that when a transaction comes in, we execute it first, then we order it, and then we validate. And that's very different from most things, most networks I've seen, where usually the transaction is ordered first, and then you execute them after they've been ordered and put into a block. So we'll go into that. This kind of gives you an outline of the things I'm going to talk through. There's a lot in here, and hopefully I have time for a demo, and I'm going to skip a couple of the ones at the end to give you time for the demo. So let's start with the architecture. So here we have a kind of a simplified version of what a Fabric network could look like. So on the right side, you have the peer. The peer is kind of the closest thing to what typical nodes are in other blockchain platforms. The peer basically has a few jobs. So there's the endorser, the committer. I'll go into detail what those are in in a couple slides. But for right now, you can just think of it as, this is the thing that keeps track of the actual blocks, right? It's receiving the blocks, it writes it to the file system, so that's what the ledger is. It's also the thing that runs the chain codes or the smart contracts, so that's what the A and the B are. And then it also is the thing that will emit events when clients, subscribe to something. They say, I want events, this is the thing that will be doing it. Then you have on the left is the ordering service. So we're collectively calling it the ordering service, but this actually can be made up of multiple nodes itself, ordering nodes. And the job of an ordering service is very simple. It's just going to order transactions. So it's going to take transactions that come in, and then it's going to create blocks and send them out to all the nodes that are there. And it doesn't do anything else. It will not look into the transactions. It won't look inside of the blocks. It won't kind of do any kind of evaluation of them. Then we'll stick inside of the Fabric network. We have members. Oh.
I'm sorry, so the ordering of them, that's just consensus, right? Or
part of the consensus. So there's consensus in the sense of the nodes in there, they have to have consensus within them about what the next block has to look like. So there's consensus there. Right now we offer Kafka as an option, which is like a message queue, but really the extra nodes are there for availability. They're not like Byzantine fault tolerant. And that's something that we are looking to add later on. And we recently added Raft. So again, Raft is crash fault tolerant, not Byzantine fault tolerant, but Raft gets us one step closer to breaking up the ordering service a little bit more. Did that answer your question? Yeah, okay. So then you have the membership services. Membership services is basically the idea of how do you organize the different identities in here, and they're typically done based on the organizations. So you have different organizations that join the network, and those organizations, they kind of manage how do they want to issue new certificates, how do they want to deal with new users, that kind of stuff. And there's a few different ways. I mean, you can manage it outside by yourself if an org wants to do that. We also give you an option to use our Fabric CA, basically a nice tool to help you do identity management and register new users. Then on the left, all the way at the end, is the client application and then the SDK. So in order for any kind of application to talk to the Fabric network, they need to use the gRPC API to talk to the order and the peer. But we've also provided SDKs so that way you can interact with these with the network easily. So the SDK, currently we support it in Go, Node, Java, and I believe we're working on Python. So that one's still in the works. So talking about the client application, typically how would users and blockchain developers interact with the ledger? So this is kind of like a blown up version of what the peer kind of looks like. We've broken the ledger down. There's two parts to it, as you can see. The ledger has the blockchain, which is the one on the right, if you look at the bottom right. And then on the left in that kind of smaller box there is the world state. So that's basically keeping track of what if you added up all the updates from all the transactions, what does the world state look like right now? So we do keep track of both. Then you have the smart contract that's running on the actual peer. So the smart contract is the only way for you to make any changes to the actual ledger. It knows how to interact, read from it, and generate writes. And as a blockchain developer, the two pieces that you're going to really be working on is one, the smart contract that's running in the peer, and then the other thing is the client application outside, which you would use the SDK to talk. And the SDK takes care of submitting transactions and also getting information about the blockchain in its current state. And then you also have events. So let's go a little bit deeper into the Fabric ledger. As I mentioned, Fabric ledger has two pieces, and they're maintained on each of the peer. It has the blockchain, which is the transaction log, and then the world state. We're going to talk about channels a little bit later, but channels are a way to kind of keep privacy, as I said, shard the ledger out. So you can think of each ledger, it's one ledger per channel. And information about that channel is stored in the Genesis block. So when you create one, you're going to be saying this is the channel, this is the ledger where I'm starting. Each of the transactions that are in the block, you're going to know who submitted it, what were the inputs, what are the functions that it was trying to call, but you will also have the read sets and the write sets. And what that is basically the key value pairs that the smart contract is reading from the world state and the key value pairs it wants to write to the world state. And then the last couple things there is the world state. We currently support LevelDB and CouchDB as the options over there. So that gives you like a little bit of an overview. Let's kind of go through what a transaction looks like. These are kind of the three different pieces that you're going to be interested or what we're going to need to pay attention to. So the first two are just different roles for a peer. The first one is a committing peer. All that means is they're going to be committing the blocks to the ledger, and they're going to be validating those blocks when they come through. They don't necessarily have to run the smart contract. They might have it, but it's not necessary for them to have it. The endorsing peer, on the other hand, is the same thing, but it must have the smart contract. It must be running them because it is important for the endorsement policy and the consensus in Fabric. And then the last thing is the ordering node. We already kind of talked about it. This is inside of the ordering service, and their only job is to take in transactions and produce blocks. And in general, this is how the consensus is achieved in Fabric. Endorse, order, validate. I like to, instead of using the word endorse, I like to say execute, because the execution of transactions only happens in that first stage. And I'll walk us through this step by step. So the first thing is, this is kind of our sample network. We have 3 peer nodes, E0, E1, E2. These are endorsing peers. And then you have the peers, P3, P4. Those two are committing peers, as in they're not actually needed for endorsement. They're just there to keep track of the ledger. But you can see that they do have smart contracts / chain codes running on them. They could. So this is the endorsement policy. When you start up a smart contract, you give it a policy and you basically say, these are all the people who have to agree to this transaction for it to be marked valid. And there are different ways you can define it. So for here, we're going to say E0, E1, and E2, they all must sign off on the transaction. And we don't really care about P3 and P4. So that's just the policy we're going to do here. The SDK, when you specify a transaction and you say this is what I want to run, the SDK is able to get the endorsement policy for that smart contract. And looking at it, it'll know that it needs to submit its transaction proposal to E0, E1, and E2. So they're going to send that. Then the next thing is the execution stage, where the endorsers are going to execute. This is the stage where they're going to get the read-write set. So they're going to generate all the information that they need to figure out what are the values being read from the ledger, what are the values being written to the ledger. Once that happens, they're going to sign it using their credentials, and then they're going to pass it back to the SDK. The SDK at this time, because it would have collected enough endorsements, is going to be able to submit the transaction. So it's going to submit it to the ordering service. So we have the one that we're following, the client application, but you can imagine that there'd be other applications also submitting transactions into this. So the ordering service will take all the transactions that it gets in, and it will produce a block. The block is then going to be delivered to all of the committing peers. So that's the endorsers, as well as the P3 and P4 over here, because everyone's going to keep track of the ledger. And you can see now that the star, which was the block, has now been added onto this ledger. At this time, this is when the peers, what they're going to do is they're going to validate all the transactions in the block. What that means is, one, they're going to check that the endorsement policy was met. If it's not, then the transaction will be marked invalid. If the endorsement policy has been met, the second thing they check is the read-write set, because things might have changed from when they got the transaction to when the transaction was actually executed. So how they do that is they check the read set. They'll read the same values from the world state, and if they match with what's in the transaction, then the updates, the writes that the transaction had, will be applied to the ledger. And if, in case that the read set doesn't match, the transaction will be marked invalid. So invalid transactions are still committed to the ledger. So you have a history of them. You'll know what transactions were submitted, but their updates will not be applied to the world state. And instead, you'll have like a demarcation saying these transactions were invalid. They didn't affect the world state at all. And the last step is for all of these things to send out their events. Okay, So let's go through channels and ordering service. I think we've talked about this a few times at this point. The only thing I'd like to add is before it used to be Solo and Kafka. Solo is meant for development purposes, not meant for production use cases. Kafka used to only be the option, but now we have Raft. Basically, we're using etcd Raft in order to do that. And they've improved on the pluggability of Fabric, and they've changed some of the interfaces to make it easier for new consensus protocols to be added in or for people to come with their own. The thing I do want to quickly touch on are channels. So channels is the way we kind of are able to separate the ledgers. In a way, I kind of think of channels as a network itself. And so when you have yeah.
Can I ask a question about the previous slide?
Yeah.
So you have these endorsers, they run whatever they need to run, they validate it, and send it to ordering service, ordering service ordered it, and now it turns out we have double spam. So it goes back to endorsers, so they see the transaction is invalid, and they all put it in the ledger as invalid transaction, and it stays.
So the transaction, it'll be logged as the transaction was submitted, but nothing would have come of the transaction. None of the changes would have been applied.
So now if I have double, what if some endorsers consider it a valid transaction and some endorsers consider it invalid transaction, and now endorsers will be in
out of sync? So it's not really possible unless because there's no manual check here, right? It's all being done automatically. And then the idea is if your read set, so for in one endorser to accept it and one endorser not to, that means their databases are already out of sync.
Yes.
And you can then track immediately back.
They run different code.
No, you won't be able to run different code. There is a validation check on making sure that you're running the same smart contract. They check the package to make sure it's the same bytes. So you have to be running the same thing. Otherwise, the contract itself won't even be available for use. Yeah. So going back here, we have channels. That's the way we separate out the ledger. There's two things how this involves with chain codes. So a chain code, when it's installed on the peer, it just means it's installed on the peer. It's not associated with anything. It's not running. You have to instantiate it. And when you instantiate it on a channel. And then that smart contract, it's kind of recorded that all the transactions of that smart contract go to that channel and that ledger. So what this means really is you can actually have the same chain code running on multiple channels. So you'll have different instances of it, and it could be the same version, but they're generating transactions for different channels, and they have access to different parts of the ledger. They won't have access to everything that chain code has. And then another thing is peers. A peer node can actually participate in multiple channels. So they can keep track of different ledgers. And it's not necessarily that they're limited or they're not allocated to a single one. And so just as an example, here's like an example of how a single channel would look. You can see everyone's kind of the same. They have the blue ledger that's E0 to E3. They all have the same chain codes, and you can see that they have the blue outlined endorsement policy. That's what the P, the purple P, is on the.
I have a question for you as well. How many channels can run concurrently?
So the thing with the channels is they're not necessarily limited. Like if you want to add more channels, you can always just add more orderers. There's no real limit on it. Obviously, a peer node that is connecting to multiple channels, it needs more space, right? It needs to store that information. So those are kind of the things, but there's no necessary limit of how many channels you can have. Yeah. Yes.
What is the life cycle of a channel? Like when you start a channel and when does a channel end?
There's no necessary end. That's the ledger. That's the network. So you think of a channel as the network, and then the whole overarching fabric network is like a network of networks, if that makes sense. So that's your ledger. The second you end it, that means that network is done.
So if a node is participating in different channels, how does the node store a different ledger?
They'll be separated. Right? They'll have different ledgers basically, so that your database-wise, they're not going to be connected. I actually don't know exactly how the database is split between the different ledgers, but the peer knows how to manage them separately. So all it thinks of, if I give you an example, right? In the file system, they're going to be stored in different locations. but they're not connected. So for example, the red ledger, you're not going to get a red block and then a blue block. It doesn't work that way. The red block is just going to keep growing red blocks, and the blue block will be stored separately with all the blue blocks, if that makes sense. Like think of them as two different files almost, right?
So if you started channel 1, channel 2, something in them, and then you said, oh, well, we don't need channel 2 anymore, and you took those nodes out, that would delete the ledger, but the information would stay in the world state?
No, because the world state is connected to the nodes. So if you get rid of all the nodes in the channel, right, then you got rid of all instances of that world state.
Oh, okay.
Yeah.
So that's divided.
Yeah. Hopefully that clarified things. Okay. So we have a single channel network, and then this is an example of how you would have if we added another channel, you can see only E0 and E3 are part of the red, and they're kind of separated out, different endorsement policies. You would have different clients talking to them, things like that. And with that, let me quickly, kind of running out of time, so I'm going to rush through the endorsement policy stuff. Basically, the way we deal with the endorsement policy, I showed you an example of what a policy kind of looks like, but in terms of the execution of them and validating them, we have two different chain codes. We call it the endorsement system chain code and the validation system chain code. And these are the pieces. So the first one is the part that actually does the execution, and then it looks and signs the transaction when a proposal comes in. And the second part is doing the validation, make sure you met the endorsement policy, and then it commits it to the ledger. So those two things are actually pluggable. So we have a default with Fabric, but you can actually take them and modify them to how you would see fit. And this is basically the syntax, the black box on the left. The last line in there, that's where you would add in your policy. And it uses and or options, and then the MSP-.role. Those are the things you can have a policy on. And really the role can either be a member, which means basically any peer of that organization, or it could be an admin, or you can be very specific and say this is the peer that has to always say yes. And just a little more of examples, you can use and, or you can do a combination, basically creating a logical expression there. And with that, let's go into a little bit of a roadmap of where the Fabric journey has been. So in 2017, we made our 1.0 release. And then starting from 1.1 to now, we try to keep a quarterly release cycle. We most recently, in April, we released 1.4.1, and we also did a 2.0 alpha. The idea is we're looking for people to test it out, use it, give feedback. This is the time to do it. And our goal is in July, we want to release 1.4.2 as well as a 2.0 release. One other important one to talk about is the 1.4 release that we released in January. We have long-term support for that one. So let me talk a little bit about, and I guess the other important thing is 1.4.1 is where we introduced draft. And then the 1.4.2 and the 2.0, I'll talk about it a little bit higher level here. So what we have, one of the things is the chain code, the interfaces, and the APIs that developers have to use. We're improving upon it to make it easier. One of the reasons is because we're no longer going to continue adding features into Composer to support Fabric. So because of that change, we want to make it easier to develop on Fabric, and that's one big thing. Identity Mixer has been added, I believe, to all the SDKs. This is in the help of being able to register, manage your user identities. So zero knowledge proofs and UTXO, these are things that are going to be added in 2.0. The UTXO is an introduction of a token. We're going to have a fab token, which is different from the mechanism that I just showed you, right? Those are assets. I'm not going to go into UTXO though. And then you have Raft consensus that got added. We're going to add a migration path from Kafka to Raft in 1.4.2 and in 2.0. And then the idea is, and this hasn't been developed yet, but we want to add a BFT consensus protocol to Fabric. So here are some getting started information. These are basically the starting tutorials that I think are good. You can find them on the Hyperledger docs. The last one, FabCar, is the example I'm going to show you today. And here, this is probably a better. Oh, I actually think, so you can take a picture of this one, but the next one's probably a little bit better because it has all the links. Let's go ahead and take that, and then everything that was on the previous slide is the first link on there, the Hyperledger docs. Then we have also linked the IBM code. This basically has a bunch of code patterns, lectures, how-tos, all this kind of information that you can use to practice and get your hands, get on a hands-on learning. And that's kind of the end of the presentation, but I do want to do a demo. But please feel free to kind of ask questions while I do things, so that way, because I don't know if we'll have time to do a Q&A exactly. Yeah.
Any questions?
Sorry. The distinction between IBM blockchain and Hyperledger Fabric, can you just give a high level of the difference?
So the IBM blockchain is using vanilla Hyperledger Fabric underneath the covers, right? What IBM blockchain platform is doing a couple of things. It's trying to manage it so it does the management of the nodes for you. It creates a nice console and a UI for you to do all of those. But the actual underlying platform itself is just Fabric. We're not doing anything secret and putting it on top. The layers that we're adding are on the outside, the external, but the base blockchain part of it is all Fabric.
Anyone else with a question?
Okay, so with that, let me quickly go through this demo. Then I think I have about 12 minutes left.
Yeah.
So can people see that if I start typing? Is that clear enough, or do we need to go bigger? Okay. If we do, just let me know. Basically, have people played with this example before, FabCar? Are people familiar with it? No, okay. So the idea is this is basically a smart contract that you can list a bunch of cars and their owners, and we can add cars to the registry, and we can change the owner of the cars, basically. It's a very simple example, not necessarily realistic, but it's just there for us to go through all the steps. So I'm going to start off showing you I have nothing running. We're going to use Docker to run a local network. The first thing I'm going to do is start Fabric, and I'm going to do it in Node, JavaScript. And I'll show you what that script is while it runs on the side. So the first thing here is, this first part over here is just to say what language we want to deploy the contract in. We have a few different versions of just the same example. It's in JavaScript, it's in TypeScript, and it's in Go. But that's just what that initial code is doing. Then the next thing what we're going to do is we're going to start the network using Docker Compose. So Docker Compose is going to have all of our elements of what we want to look at. So just to give you an idea of what that looks like. This is kind of what the network looks like. We have a CA, Fabric CA, and it just has some of these starting environment variables configurations. We have a single orderer, and then we have one peer. And that's basically our network. And then right here, because of this is our network, this is also our connection output. This is basically a configuration, so that way we can give it to our client applications how to connect to the network. So since we're here, I just want to show you, they kind of outline, they're the same, one orderer, one peer, and then we have the actual URLs of the two. And you can see it's using gRPC to communicate with them. So with that, let me go back to the start script. So the first thing we're going to do is after the network comes up, we're going to install FabCar. That's the name of the contract that we want to do. And then after that, we're going to instantiate it. And here is where we add the channel. We're going to say we want to instantiate it on my channel. And then the last step here, we're just going to invoke it. And by invoke, that means we want to actually run a transaction on it. And the function we're going to do is init ledger. So using that, let's go and check out what this FabCar example looks like. JavaScript. So this is the actual contract. So the first thing here you can notice is we are pulling in the contract module. This is one of the newer styles of chain code development for Node. The idea is you would take your contract and you would extend that contract object. And all the functions, they need to take this context object in. That context object is the link for the functions to talk to the ledger on Fabric. So the init ledger, that's the first call that we were invoking in the script. Basically, all it's done is populating the current state, the world state. And we just put in a bunch of cars here. You can see it has the color, the make, the model, and the owner. And nothing else, that's pretty much there. Then the other things that we have here is the query car. So you can take like an ID number, and then you can query information about the car. You can create a new car. You can query all of them. Right now, we're only going to be able to show you the first 1,000. Again, just a simple example for us to play with. And then the last option you have is changing the car owner. So that's just a quick overview of what our what our contract looks like. So here we can see the script has finished, and just to show you what the output looks like, we now have things running. So the first one, let's start right here. So right here is the peer. Then you have CouchDB, which is supporting the peer, so that's where the world state is being stored. Then you have a single orderer, because we only had one. And then up here at the top is the chain code container. So that's the fab car instance, what we're running, and that's actually connected to the peer. And then at the very bottom, we have Fabric CA. So in this example, the typical idea is we're going to pretend to be different roles. So as you start off, you'd probably be an admin. And so the first step you would want to do is enroll as yourself. And what that's really doing, by enrolling, I mean, we're going to talk to Fabric CA, and we're going to say, I'm the admin. Here are my credentials. Can I get my cert so I can sign? So you can see right now I have nothing. Let's go into JavaScript. You can see right now I don't have a directory called wallet. We're going to create one in just a second. And before we do that, let's go and look at what Enroll admin does. So this is using a couple of things. The Fabric CA client, this is how you talk to Fabric CA. Then the next thing is we have like our little wallet implementation. This is just a way to store your credentials and be able to sign transactions that come and go. That connection, that JSON that I was showing before that had the URLs and everything, we're going to pass that along. That this is how we're going to tell the Fabric network, or how to connect to the Fabric network. And then this is our main function here. The first thing we're going to do is we want to figure out where the CA is. We're going to create our wallet. We're going to check in the wallet that the admin doesn't exist already. And then we're going to enroll as the admin. And it's very secure, as you can see, admin and admin PW. And then from there, we're going to create that identity. We're going to say, whatever I enrolled as, create that identity in my wallet. And we should see some credentials the second we do that. So let's go in and do that. And we can see that it's successful. If I do an ls, we now have a wallet. And then we can look through here. And there's an admin, and there's our private and public key. So with this, typically you would expect that admins are not the only ones interacting on the network, and the admins aren't going to give their credentials to everyone. So as a user, what an admin would have to do is register a new user. So that's their next step, what we're going to do. You can see the beginning part of this script looks exactly the same as the last one. The only difference here is now we're going to check for user 1 before we register another user 1. And then what we're going to do is we're going to connect as the admin. So that's what the gateway connect is. Then after we do that, we're going to get the current identity. So basically, it's going to load up those certs that we have. And then the next thing it's going to do is register. It's going to say, I want to create a new user. It's going to be part of org 1. This is the role that they have. And then the CA will enroll that, and then we're going to add that into our wallet. That's what the last couple steps are. So we do that. Register user. Do that. And then before wallet used to only have admin. Now we have user 1, and we have the private and public keys for that. So now that we've done that, let's actually interact with our network, because we have that. To make this a little more fun, let's do this. I'm going to kind of just track the logs here, so that way we can see what's happening of the peer. So we'll start here. And then the first thing I want to do is, because we already put some starting data in there, let's just query that. So I'm going to look at this. So again, this script, the beginning part, you're going to see this all looks very familiar. Then the next thing is we're going to connect now as user 1. And then this is the first time we've actually had to specify the channel and the chain code, the smart contract, because now we want to actually make transactions, and now we need to specify information about it. The first thing is, let's do just the basic query all cars. You can see we're doing contract.evaluate transaction. So when you do evaluate transaction, what that means is we just want you to query. We don't want to submit anything. It's a query. Don't worry about trying to get all the endorsements, right? So with that, let's do query. It's going to come back. And now we have that initial list that we had. To test out a little bit more, let's take a single key. So we have key 4 somewhere. Or OK, let's do key 3. We can see that. It's a yellow. It's a car make of Volkswagen. It's a Passat. And the owner is Max. So let's edit this to do that. You can take, and then I'm going to query the car, and then we're going to give it the ID, which is car 3. And then we can node query that, and then we get back the same record that we saw in the entire ledger. So that's fun. I mean, we queried it, but it would be a little more interesting if we could actually make some transactions, right? So the first thing is, let's look at this Invoke Script. Let's do this. What we have here, again, the same, pretty much everything looks the same, except right here we do contract.submit transaction. That's different from before. Submit is basically saying, I want this to actually be a valid transaction. I want you to go through the whole consensus, get all the endorsements, and things like that. And this is only something that the SDK needs to know, right? Because the SDK is in charge of doing this whole operation. So with that, let's bring this back up so you guys can see what happens. Oh, well, OK, that was a query, but you can see what happens here is, you just get a unary call complete. You can see that it's going into fab car, and then that's about it. And then as a comparison, now you're going to see what an invoke does. And when you do an invoke, you immediately will get the similar thing right here. This is the execution point, because it's going to look exactly the same. And the next thing is you can see that it received the block, so it went to the orderer, then the orderer sent the block, and then we've now committed the block. Now, with this, because we created a new one, let's edit our query to now query for that specific one, which was car 12. And we get back the new kind of car, which is the Honda Accord owned by Tom. And so with that, that's just like a quick little demo. Obviously, you can see how this could become bigger. You can use the node. We're just using regular JavaScript here to interact with everything, and you can make this work for your use cases and things like that. Are there any questions before I end? No? OK. Well, then thank you.